This video is on solving and graphing inequalities. Any notes should be copied down on your note sheet. First, a definition for inequality, a mathematical statement saying that two values may be equal, greater than, or less than each other. Again, this should be copied down in your note sheet. These are examples of inequalities. H is less than 54, H is greater than 8, M is less than or equal to 3, and M is greater than or equal to 10. So again, these are examples of inequalities. Graphing inequalities. Solutions to inequalities are graphed on a number line. Solutions are all values that make an inequality true. Less than and greater than use an open circle that looks like this, and you'll see it once we start graphing on a number line. However, less than or equal to and greater than or equal to use a closed circle that looks like this when we graph the solution on a number line. Let's take a look at we do number 1. If you're good with solving equations, you should be okay with solving inequalities. We just have to graph the solution. So 2x plus 3 is greater than 19. The first step, I want to get rid of my constant, so I subtract 3 from both sides. These cancel out and I bring down my 2x, bring down my greater than, 19 minus 3 I know is 16. So then I divide by my coefficient, and I get x is greater than 16 divided by 2 I know is 8. So x is greater than 8. This is saying that any number that's greater than 8, when I plug it back into my inequality, will make it true. So let's graph our solution. So I can sketch a number line. I don't even have to make a whole number line. Let me just plot where 0 is. And then 8, I can plot here, estimate where it is. So x is greater than 8, so I use my open circle. And then I have to shade the area where my solutions are. So if x is greater than 8, that's anything to the right of 8. So anything to the right of 8 or greater than 8 will make this inequality true. So we do number 1, x is greater than 8, and then we graph the solution. Let's take a look at we do number 2. First, there's a special rule that we should know. When you divide by a negative coefficient, you flip the inequality symbol. So this rule should be copied down in your notes. So let's take a look at we do number 2 with the special rule in mind. Negative 3x plus 5 is less than or equal to 20. And so see here I have a negative coefficient. So let's subtract 5 from both sides. I get negative 3x is less than or equal to 20 minus 5 I know is 15. So remember to bring down your coefficient. If it's negative, it has to stay negative. And then I divide both sides by negative 3. And I get x is, since I divided by a negative coefficient, I flip my symbol. So now x is greater than or equal to negative 5. Because 15 divided by negative 3, positive divided by negative is negative. So negative 5. And then I have to graph my solution. Remember to just sketch a number line. Mark off where 0 is. And then negative 5 is to the left of 0. And since it's greater than or equal to, I used a closed circle. So any number greater than or equal to negative 5 should be to the right of it. It can be negative 5 or anything to the right of it. So any number negative 5 or greater will make this inequality true. So these are your practice problems, numbers 1, 2, and 3. Complete them on your practice sheet. You can pause the video if you'd like and do them on your own, and then unpause the video and see if you got it correct. So let's see how you did with number 1. 9x minus 4 is less than 5. So get rid of my constant. I add 4 to both sides. On my left side I have 9x, bring down my inequality symbol, 5 plus 4 is 9, divide both sides by 9, and I get x is less than 1. And then let's graph our solution of x is less than 1. Remember, just sketch a number line, so here's 0. And then 1 I know is to the right of 0. Since it's less than, I use an open circle. And then it's saying x is less than 1, so any number has to be less than 1. So that's everything to the left of 1 will be my solution. So x is less than 1. Let's see how you did with number 2. X minus 1 divided by 3 is less than or equal to 7. This equation looks a little different, but it's still, we can use our knowledge of solving equations to help us figure out the inequality. So since I'm dividing both sides by 3, I want to multiply both sides by 3 to get rid of that denominator. So these cancel out, and I get x minus 1 is less than or equal to 7 times 3 is 21. So now I have a one-step inequality. Get rid of my constant, I add 1 to both sides, and I get x is less than or equal to 22. And then let's graph our solution. So I sketch my number line, mark off 0, mark off 22, and since it's x is less than or equal to, I use a closed circle, and then it's saying any number that's 22 or less than that will be an answer to my inequality, a solution. So I shade in my number line everything to the left of 22. Let's see how you did with number 3. Negative 5x minus 1 is greater than 4. I know I have to keep in mind my special rule because my coefficient is negative. So I add 1 to both sides. Bring down my negative 5x, bring down my inequality symbol. 4 plus 1 I know is 5. Divide both sides by negative 5. And I get x, and remember to flip my inequality symbol. So now x becomes less than negative 1. And then let's graph our solution. Sketch our number line. Mark off 0. So x is less than negative 1, I mark off negative 1. And since it's just less than symbol, I use my open circle. And I want to show everything that's less than negative 1. So I'm going to shade everything to the left of negative 1, because these are all less than negative 1. So number 3, x is less than negative 1. Remember to keep in mind the special rule when we divide by a negative coefficient, flip the symbol. Here are your last 3 practice problems, numbers 4, 5, and 6. Copy these down and do them on your note sheet. You can pause the video if you'd like and do them on your own, and then you can check back with the video to make sure you got it correct. So let's take a look at number 4. 3x plus 7 is less than or equal to negative 5. So I just subtract 7 from both sides. I get 3x is less than or equal to negative 5 minus 7. I can keep change, so negative 5. Keep my first number, change subtraction to addition, change the second number to its opposite. Negative 5 plus negative 7 is negative 12. So 3x is less than or equal to negative 12. Divide by my coefficient, and I get x is less than or equal to negative 4. So for this, I don't have to do my special rule because my coefficient was negative, even though here you might ask, well, don't I have to flip my symbol? But the coefficient is positive, not negative. So only do that with a negative coefficient. And then plot my solution, graph my solution, mark off 0, and then find negative 4 is about here. Less than or equal to, I use a closed circle. So it's saying x is less than or equal to negative 4. So negative 4 is included in my solution, and everything to the left of negative 4 will make my inequality true. because it's less than or equal to -4. Let's see how you did with number 5. 2x plus 11 is greater than 3, so I add 11 to both sides. Bring down my 2x is greater than 11 plus 3 is 14. Divide by my coefficient. I get x is greater than 7. Then I plot it. Mark off 0. Plot 7. Greater than, I use an open circle. So it's saying any number that's greater than 7, so anything to the right of 7, will make my inequality true and be a solution to my inequality. Let's see how you did with the last one. -7x plus 14 is less than or equal to 28. I know I have to keep in mind my special rule because the coefficient is negative. So I subtract 14 from both sides. Bring down my -7x. Bring down my inequality symbol. 28 minus 14 I know is 14. Then divide by -7. And I get x is, remember to flip the inequality symbol. So x is greater than or equal to -2. So that's my solution, so now I have to just graph it. Mark off my 0, plot -2. Since it's greater than or equal to, I use a closed circle. And it's saying any number greater than or equal to -2 will make my inequality true. So any number to the right of -2 and -2 itself will make my inequality true. So here's your exit ticket. Solve and graph each inequality and its solution. This should be done on a separate sheet of paper. Make sure you show your steps and make sure you graph using the correct circle, open or closed, depending on the inequality symbol. Turn it in when you're finished.